Let's solve one more question with partial derivatives, and let's do it for the first order and the second order as well. So we have q as a function of x and y, and let's start differentiating with respect to x. So everything besides x will be held as a constant. From ln of 5x derivative with respect to x, so let's write ln of 5x derivative with respect to x plus 3x times ln of y derivative with respect to x. What is the logarithmic derivative? That's just 1 over 5x, but because we have an expression of x, we use the chain rule, so we have to differentiate the expression itself, 5x derivative with respect to x. Plus, what is the constant here? Everything besides x, so that's 3 and ln y. So we have 3 times ln y is a constant, and then we differentiate x, so that's going to be x derivative with respect to x. Okay, 5x derivative with respect to x is just 5 divided by 5x plus 3 times ln y, because x derivative is just 1. So 5 divided by 5, well, that cancels out. So we have 1 over x plus 3 times ln of y. And that's going to be just the first derivative, the first order. Let's solve for the second order derivative. What happens if we want to differentiate this thing with respect to x again? So q derivative with respect to x and with respect to x one more time. Well, that's the derivative of what we just did, all of it differentiated with respect to x again. So that's 1 over x plus 3 times ln of y derivative with respect to x. What is 1 over x derivative with respect to x? Well, that's x to the power of minus 1 derivative with respect to x. Let's write it like that. And what's 3 ln y derivative with respect to x? Well, that's a constant only. There's no x inside it, and we know that the constant derivative is 0, so the result is just 0. Now, what is x to the power minus 1 derivative? We take the power down, and then we have x to the power of minus 2. So it's minus 1 over x squared, and that's it. Now, let's do the same, but now the second derivative is going to be with respect to y. So we have q derivative with respect to x, and then with respect to y. Q derivative with respect to x, and then with respect to y. That's the q derivative with respect to x, and all of it differentiated again with respect to y. So that was the first derivative, 1 over x plus 3 times ln of y, and now we differentiate this with respect to y. So from the first part we have just the constant, because x is held as a constant, the derivative of a constant is just 0, plus 3 is a constant, and we take the derivative of ln y. So that's just 3 times 1 over y, and that's equal to 3 over y. So we got that. Now let's solve also the derivative with respect to y and the second derivative with respect to y. So q derivative with respect to y. Let's go to this side a bit so we can see the function. Actually, let me zoom out better so we can see everything. Over here, q derivative with respect to y. Well, from the first part we have just x, so the derivative of that is 0 because it's a constant, plus 3x times ln y derivative. Well, 3x is the constant, so we keep it like that, and we differentiate ln y. So that's just 3x times 1 over y, and that's equal to 3x divided by y. Now, let's do the derivative of y with respect to y again. Q derivative with respect to y one more time. So we saw this is the derivative of, let me change the color actually. We saw that the derivative of q with respect to y is equal to 3x over y. And we differentiate this with respect to y one more time. Well, what is the constant here? That's just 3x times the derivative of 1 over y with respect to y. That's 3x times y to the power of minus 1 derivative with respect to y. And that's equal to 3x times, let's take the power down, minus 1 times y to the power of minus 2. So that's minus 3x divided by y squared. And that's it. We are done.